Morning, students. So, last class, right? So, in the last class, we are going to learn about what are the heredity experiments, right? So, Mendel proposed Mendel to conduct two experiments like a monohybrid cross and a dihybrid cross. So, according to monohybrid cross and a dihybrid cross, Mendel gives or provide three laws of a heredity. Heredity laws are three laws. Mendel provide three laws for heredity. So, what are the laws of heredity or laws of genetics? You know that in this class. Laws of heredity or laws of genetics. Laws of genetics. So, laws of genetics. In the genetics, there are three laws. All three laws given by John Kruger Mendel. So, first law, that is law of segregation. Law of segregation. So, this is the first law. And second law, law of independent assortment. Law of independent assortment. And third one is law of dominance. Law of dominance. So these are the three laws given by John Kruger Mendel. So the first law, that is law of segregation. What do you mean by law of segregation? So here, you know that before we will discuss about, learn about the laws of genetics. You know that what do you mean by genes? So these genes are the units. Which units? Hereditary units. So these hereditary units carry the characters carry the information from one generation to another generation. Or hereditary genes are the hereditary units to carry the information or characters from parents to offspring, from generation to generation. That is nothing but genes, right? So what do you mean by alleles? Alleles. So alleles are the plural word. Plural word. Allele is the singular word. So alleles are the different forms of genes. Different forms of genes. Different forms of genes. Different forms of genes is nothing but alleles. Different forms of gene, that is nothing but allele. Different forms of genes, nothing but alleles. Plural. Different form of gene is nothing but allele. So genes are the hereditary units to carry the information from one generation to another generation. Alleles are the different forms of genes to carry the information from one generation to another generation. Got it? So let us go for the law of segregation. What do you mean by law of segregation? Law of segregation is nothing but the law says that what? During the gamete formation, during the gamete formation, Alleles. Alleles for each gene. Alleles for each gene segregate from each other. Segregate from each other. The gamete carry single gene. So this is the first law, that is law of segregation. Law of segregation is nothing but during the gamete formation. So during the gamete formation is the process. Is it clear? Which process? The cell division process. What do you mean by cell division? You know that very well. Cell division is nothing but, you know, already learned about the definition for cell division in the 9th class. So if a parental cell have been changed into daughter cells, or mother cell can be converted into daughter cells. You know that very well about the cell division. In the cell division there are two types. One is the mitosis. Another one is meiosis. Mitosis and meiosis. So mitosis cell division is the vegetative reproduction. Vegetative cell division. So this is the vegetative cell division. But meiosis is the reproductive cell division. Reproductive cell division. So this is the reproductive cell division. Which one? Meiosis. So during the gamete formation, it is nothing but a reproductive cell division. That is meiosis. During the meiosis, so alleles for each gene. Alleles for each gene means alleles, you know that very well, different forms of genes, right? So in that alleles is nothing but different forms of genes. So in the different forms of genes, only different forms of genes segregate, that means bifurcate, can transfer next generation, right? Segregate from each other. A group of genes is nothing but alleles, right? Different forms of genes is nothing but alleles. So in the alleles of each gene can segregate means transfer. So can segregate from each other. The gamete carry single gene. Each gamete carry single gene. That is nothing but law of segregation. Law of segregation is nothing but it is the law. The law says that what? During the gamete formation, that means meiosis cell division. So the group of genes, that is nothing but alleles for each gene. Alleles for each gene segregate from each other. And a group of genes group of genes not only one, all the genes can segregate, right? Random segregate agtave. So segregate aganga avali gamete formation aguttalla. The formation of single gamete occupy to carry only single gene. That is nothing but law of segregation. Is it clear? Law of segregation is nothing but during the gamete formation, alleles for each gene segregate from each other. The gamete carry single gene. That is nothing but law of segregation. Is it clear? Right. And the next one, law of independent assortment. So law of independent assortment. So the next law of independent assortment. So you know that. So in a meiosis cell division or mitosis cell division. So mitosis cell division is the vegetative cell division and meiosis is the reproductive cell division. So in the both cell division, there are 4 phases are there. How many phases? 4 phases. You know that one of the 4 phases during the cell division, one is the interphase. Interphase. Second one is the metaphase. Third one is anaphase. Anaphase. And fourth one is telophase. Telophase. So these are the 4 phases during the cell division. So in the interphase, so this is the first division, the first phase, and during the second phase of cell division, that is nothing but metaphase. Meiosis is the type of cell division. During the meiosis cell division, metaphase condition, the group of alleles in a one mother cell. So here there is a one mother cell is there, gamete. So here there is a group of alleles are there. Group of alleles. You can take 2 sets of chromosomes. 2 sets of chromosomes. 2 sets of chromosomes. Here are the 2 sets of chromosomes. So one is the dominant. So B. So this is the small b. So small b it indicates recessive gene, and capital B it indicates dominant. And here also same capital C. So this is one is the small c. That is nothing but recessive. So one pair is the recessive, one pair is the dominant. Is it clear? How many chromosomes are there? 4 chromosomes. So each chromosomes. So here during the metaphase condition, during the meiosis cell division, so these chromosomes, right? So first time the chromosomes alignment, the alignment of chromosomes in a metaphase condition, the chromosomes are arrived in the equilateral stage. Equilateral stage. So this is the equilateral. So this is the arrangement of chromosomes or arrangement of genes. Here there is the arrangement. So here the group of the genes in the cell. So these arrangement, alignment of genes or chromosomes, alignment of chromosomes in the cells. So these chromosomes can segregate independently. You know that randomness means, you know that the Brownian movement. What do you mean by Brownian movement? You know that the Brownian movement is nothing but the movement of pollen grains by randomly. So this Brownian movement is discovered by which one? Robert Brown. Robert Brown, he is the scientist to use or provide the movement of dust particles, the movement of particles in a flower, in a pond water. In a pond there is some water, aquatic plants, there is a pollen grains. So these pollen grains can move from one place to another place with randomly. That is nothing but Brownian movement. You know that the Tyndall effect. Tyndall effect is the effect. So that is nothing but if when the light is passed into the room, so in the light path there is a large number of dust particles can move from one place to another place randomly. So that is nothing but randomness. Andra complete ಆಗಿ ಒಂದೇ ಇದರೊಳಗೆ there is no fixed position. That is nothing but randomness. So here also the arrangement of chromosomes segregate or transfer to next cells by randomness. So ಹಿಂದೆ ಇರಬೇಕಂತ ಏನಿಲ್ಲ, ಫಿಕ್ಸ್ಡ್ ಪೊಸಿಷನ್ ಒಳಗೆ ಅಲೈನ್ಮೆಂಟ್ ಆಗಬೇಕು ಅನ್ನೋದೇನಿಲ್ಲ. ಅವಾಗ ಏನಾಗಬಹುದು, ಸೊ ಒನ್ ರೆಸಿಸ್ಟಿವ್ ಜೀನ್ ಬರ್ಬೋದು, ಒಂದು ಡಾಮಿನೆಂಟ್ ಜೀನ್ ಬರ್ಬೋದು, ಅಥವಾ ಎರಡು ಡಾಮಿನೆಂಟ್ ಜೀನ್ಸ್ ಬರ್ಬೋದು, ಅಥವಾ ಎರಡು genes ಬರ್ಬೋದು. So that is nothing but law of independent assortment. So law of independent assortment is nothing but the set of chromosomes for each gene. So the genes can transfer to next generation with any position. That is nothing but there is no fixed position. Alignment should be randomness. That is nothing but the law of independent assortment. And the third one is law of dominance. You know that very well, monohybrid cross. So Mendel to collect to choose the top plant and another one is dog plant. So during the cross pollination, so the top plant crossing between dog plant, we can get the intermediate plants. So this intermediate plants having the same one dominant character and another one recessive character. So in a plant, both the properties are there. One is the dominant, another one is the recessive. But dominant character becomes expressed out, but recessive does not express. So that is the law of dominance. The law of dominance if is there, the tall plant crossing between any two key plants like a tall plant and a dog plant. So in the first clear generation, the cross pollination takes place. During the cross pollination, we can get the intermediate plants. So in a we can call it intermediate plants, but basically they are not intermediate. They are a tall plant because law of dominance. Law of dominance means the dominant character becomes expressed out and the recessive character does not express. So this is the law of dominance. Is it clear? Right. And the third one, next concept, that is sex determination. Sex determination. So what do you mean by sex determination? Who is determiner of the sex? Sex determination. Sex determination is nothing but law. So you know that. So in a father, 46 chromosomes. In a mother, 46 chromosomes. Out of 46 chromosomes, 44 chromosomes for characters. Right? Here also 44 chromosomes for characters. Because your father and mother comes from different family. Is it clear? So both these two are the different organisms. So one is the male, another one is the female. So these male and female, your father and mother, crossing between father and mother. So here there is a 46 chromosome, 44 chromosomes for characters, 2 chromosomes for sex chromosomes. These are the sex chromosomes. So here also 2 sex chromosomes. Sex chromosome. So 22 sets of chromosomes for characters, 1 set of chromosomes for sex chromosomes. Here characters. Right? So 22 pairs of chromosomes for characters, 1 set of chromosomes for sex to determine the sex. So here mother having this is a 1 set of sex chromosome, that is uppercase of X. Uppercase of X is means capital letter X. That is nothing but. So these are the 1 set of sex chromosome in a mother. So in a father, so these are the sex chromosomes in a father. So sex chromosomes in a father and the sex chromosomes in a mother. So sex chromosomes in a mother always X, uppercase X. But in a father, uppercase X, lowercase y. So these are the sex chromosomes in a father. These are the sex chromosomes in a mother. During the reproduction, so if a father can able to donate the X chromosome, uppercase X chromosome, and mother is always to donate the X chromosomes only for many times. ಎಷ್ಟು ಸಲ ಡೊನೇಟ್ ಮಾಡಿದ್ರು, ಏನು ಡೊನೇಟ್ ಮಾಡಬೇಕು, X chromosome ಡೊನೇಟ್ ಮಾಡಬೇಕು. ಹಾಗಾಗಿ here also X. So the newborn baby becomes female. The newborn baby becomes female. If the father can able to donate the Y chromosome and mother always donate X chromosome, the newborn baby becomes male. Newborn baby becomes male. So who is the determiner sex of a child? You know that very well. Father. Father is the sex determiner. So father will determine the sex of a child because father having a uppercase X, lowercase y. That is nothing but different chromosomes. Different chromosomes. One is X chromosome, the other Y chromosome. Both are different chromosomes. But here identical chromosomes are there in the mother. That is XX. If a mother always donate XX chromosome, only X chromosome. But father sometimes they can donate. He can donate X chromosome, either Y chromosome. Either X chromosome and either Y. If father can donate X chromosome, mother always donate X chromosome, the newborn baby becomes female. If father can donate Y chromosome, the mother always donate X chromosome, XY is nothing but male. Is it clear? If XX chromosomes, that is nothing but female, XY chromosome is nothing but male. Is it clear? So this is the sex determination of a child. So this completes your heredity. Evolution part is skipped in this year. Is it clear? You know that very well. The monohybrid cross, dihybrid cross, right? And laws of heredity and sex determination. Sex determination. So these are the concepts you are going to learn. These concepts are the important concepts for your examination, right?